Our next speaker is Lucas Prestianni. Lucas is from the Department of Chemical and Biological Engineering. The title of Lucas's talk tonight is Battling Cancer with Flavonoids. Thank you, Lucas.
Will we ever find a cure to cancer? Probably not. Why do I say this? It's because of the frustrating variability of cancer. Cancer comes in many different shapes and sizes, and we often have to change our approach to fighting cancer based off of many factors, like the location of the cancer in your body, the type of cell that has mutated to become cancer, and even the nature of the mutation itself. That's why oftentimes when you hear someone looking to develop a cure for cancer, they're probably looking to battle one or two problems associated with some forms of cancer. That is, however, exactly what I'm looking to do. I want to fight something called multi-drug resistance, which is especially prevalent among cancer relapse patients. As oftentimes what happens is you do your first round of chemo, everything's going great, your cancer's in remission, but what happens is the cancer comes back stronger because what we've done is selectively killed off the weaker cancer cells and left behind those that are more resilient. So what is this multi-drug resistance and how can we fight it? Well, multi-drug resistance is caused by more than just one mechanism. Much like everything with cancer, it's variable. That being said, a large contributing factor to this is a high presence of pumps on the surface of these cancer cells. These pumps work by taking our chemotherapy drugs, which work by getting inside the cell and coming from the inside, and they pump them out fairly indiscriminately at a very high rate, making chemotherapy ineffective. So what I want to do is design some sort of assisting drug, something that comes along and interacts with these pumps in a way that allows us to disable them long enough to trap our drugs inside. That's where my research with flavonoids like quercetin comes into play. Flavonoids are naturally occurring compounds, and they're found in things like onions and citrus fruits. And because of that, our bodies are used to them as they're in our natural diets, and they're going to have minimal adverse side effects. Quercetin is also appealing as this assisting drug because it's already been shown to be able to fight multi-drug resistance among some animal cell lines. However, quercetin has two main weaknesses. For one, it's very hard to dissolve a large amount in water, and two, when it is dissolved in water, it degrades over time very quickly. And this makes it very difficult to have high amounts in your blood, which is where we need it to be in order to be effective. So what I'm looking to do is create flavonoid nanoparticles. And what we're doing is we're taking our quercetin molecule and we're attaching some sort of metal, like iron, in 1, 2, or 3 locations of the molecule. And this iron should act as a barrier, blocking the ways at which quercetin likes to degrade with water, and also at the same time increase the solubility. Once we make these molecules, we want to test them alongside chemotherapy to see if we can answer a question, which is, do these flavonoid nanoparticles actually block these pumps on these cells, and as a result, help fight multi-drug resistance in cancer like breast cancer? Now, I want to reiterate a point here. We're not looking to make a cure for cancer. We're looking to fight one mechanism associated with one problem found in some types of cancer. That being said, due to the high prevalence of cancer in our society, we believe if our drug is found to be effective, it could help millions of people globally and reduce the risks of cancer relapse. Thank you for your time.